My name is Russ Sorrells. This is IndustryCast, where we go live at 11:30 every Wednesday Eastern Time to talk about different processes, different ideas, concepts, technologies, personal growth, anything manufacturing related. Our mission is to help our customers. We deal with a lot of manufacturing engineers, help our manufacturing engineers grow their abilities and skills in an effort to be able to have and add more value to their work. And then obviously increasing their value. Ideally, that's going to increase their value to their business and therefore hopefully command some more money as a result. So that's what growing our value is all about. So that's what we want to help do, pour into our customers with these brief conversations, 30 minutes, just very, very detailed. So as I mentioned, today we've got Rick Oppedisano. Rick, thanks so much for hopping on. I know some of you might have anticipated us having a conversation about parts feeding with Weber. Unfortunately, given the circumstances of last week with all of the weather that created quite a challenge for their business. So they've had to do a lot of customer service that was supposed to be done this week, double down and get it taken care of this week. And that is taking some of their technical folks that were going to be on the call with us out of not able to be on this call because they're servicing customers, which is the right place to be for sure. So Rick, thanks so much for pivoting and hopping on the call with us today. Rick, first of all, tell us a little bit about Delta Bravo.
Okay, so Delta Bravo, we've been around since 2016, and what we do is we work with manufacturers to help them leverage the data that they're currently collecting to create new data and a different kind of data, predictive data. Okay, so the idea of saying, okay, how can we take the information that we're collecting today to get in front of unplanned downtime, get in front of cost of poor quality, get in front of scrap, be able to understand what's influencing those things and use that data to change those outcomes into something more favorable for the business. Make sense?
So more of a proactive versus reactive approach?
Yeah, so, like I said, we started, back in 2015, 2016, hey, Chris. When we started up, our first customer, you'd mentioned the weather being a problem for Weber. Our first customer was actually AccuWeather, and what they had sought to do was improve the prediction capabilities for weather. And so what we found very quickly is that this is really hard. AccuWeather had 90,000 different IoT devices out there collecting weather data across every zip code, collecting 40 billion data requests a day on weather quality, several, hundreds of different metrics. And so what we found is that a lot of the solutions on the market and a lot of the ways that people were going about doing this, was really, really hard and very manual. So what we decided to do at that time was to say, hey, is there a way that we can automate this? Because AccuWeather taught us really two very important lessons. The first is the value of prediction. All right, when we talk about being proactive or reactive, it all comes down to the value of prediction. And so they taught us that there was a high value in certain places for prediction, right? And the second thing they taught us is how complex bringing all of this data in to create those predictive models can be. So what we did is we set about to build a software product and a system that could help us automate all the hard, time-consuming, and complex aspects of bringing that data together to create these predictive models and then integrate those predictive models into how the customer actually works. I mean, there's a lot of fanciness out there in technology, right? Where we say, hey, I can do this. But in a manufacturing setting, if it doesn't fit into the way that we're working today, if it requires the manufacturer to change in a significant way, that is a detractive scenario and not an additive one. And so what we found very quickly from the beginning is that there are certain industries that place a higher value on prediction than others. And then we said, okay, manufacturing is one of those industries. And then we said, what's interesting about manufacturing is that while they have a high value on prediction, they also have a high degree of complexity in the systems that they're using to collect data. They have a high degree of complexity in the processes, and they really have a high requirement for integrating within the way they work today. And so that's really what we built our business around, was the idea of focusing, targeting manufacturers. We call our solution an industrial strength predictive analytics solution because it's built to handle these unwieldy, unconventional, massive, and wild data sets, put these things together, then integrate models into systems that work for the customer.
Interesting. So, Rick, tell me about, in manufacturing, one of the biggest challenges that we face is a lot of legacy data, number one. That's a challenge. How do we utilize that data to help us see better into our processes and be more predictive and I want you to talk about that, but then also the dissimilar streams of data that are out there, right? We've got an Atlas Copco, we've got a Cincinnati Test Systems leak tester that's got data. We've got data coming from all different sources: torque guns, press systems, functional testers. And it's all formatted in a different way. And I know that's one of the bigger challenges as it relates to getting our arms around that data and utilizing it in a meaningful way.
Yeah, so a lot to unpack there. I'll try to do it quickly, clearly. So number one, anytime that you are attempting to predict an outcome in the future, you have to have a very clear understanding of what influenced that outcome in the past. Okay, so the idea of having legacy data, historic data is pretty critical to getting a predictive model out in an accurate way fairly quickly. All right, so that's number one. So we love companies that have a good bit of legacy data. The next question is, okay, is that data coming in formats that we can use, in frequencies that we can use? And what's interesting about the big picture is that if you look at so we really focus on 5 use cases, okay? We deal with predictive maintenance, predictive quality, scrap reduction, demand forecasting, and inventory movement forecasting. That's it, all right? And when you think about any one of those, let's just take predictive maintenance, for example. Actually, predictive quality is even better, where predictive quality is not a function of the performance of one machine. And this is where most manufacturers are today, right? Is that they've all embraced this concept of Industry 4.0, where we want to heavily invest in collecting data from all of our systems so that we can understand how to operate more cost effectively, more efficiently. The challenge they've run into is that each of those systems are siloed. They all collect data on themselves, their own way, right? But the problem can't be solved until you put them all together and understand how they work together. So for example, we do some quality data, some predictive quality stuff with Rolls-Royce. We do some with a couple of monomer polymer companies. And what we're doing is the big problem that they had is that they couldn't seem to solve an aggregate quality problem because they were just looking at each of the inputs individually. They didn't understand how to bring those inputs together, correlate the outcome based on certain behaviors within each of those inputs that influence the behaviors of others. Okay, and so that's really what we're doing here. When we step back and look at this and say, okay, this sounds kind of wild. Imagine taking exports from all of your data sources. Let's just say you want to kick them out there like a spreadsheet, right? So imagine having 5 different spreadsheets with each one of them has 150 columns and 300,000 rows. They're all different data points. They're all collected at different times and in different ways. Maybe one collects data every 2 seconds. Maybe another collects data just once a day. So maybe one's manual, right? Manual entry as opposed to automated collection. So when you put all those things together, man, it makes it really hard to make hide nor hair of what's going on. And so this is where people tend to be reactive. This is where people tend to be anecdotal, and where people tend to take data and use it for making an even more wrong decision than they would have made without having the data, right? Because ultimately, anytime that you give any human, historic data, they're going to apply their bias to it, the personal bias. That's going to be based on their interpretation of the value of that information specific to their priorities, okay? So my priorities as a maintenance guy are to move towards a condition-based maintenance cycle. Highly unlikely that I'm going to talk to the quality guy about his priorities, all right? Secondly, when the quality guy looks at data, it could be the same data as the maintenance guy is looking at, but they're going to have 2 completely different opinions on why that data is doing what it's doing, the value of that information, and what they can do with it. Okay, so our goal is to bring these data sets together, help and draw correlations on how each machine and each data metric in the process influences one another to predict performance degradation, to predict oncoming quality issues. And then we work with the customer to find out, hey, where in the process can we actually change this outcome? So if you have a 6-step process and you can predict steps 4 and 5 perfectly, if the operator can't go in there and use that prediction to change something in step 4 or 5, then it's not really worth a lot, right? Sure. So what we try to do is pull that data together, help the customer understand how each data point influences the other throughout that process, be able to predict the behavior of that process, and then help them understand and identify where in that process they can make a proactive change that'll result in a better outcome, whether that's more uptime, better throughput, reduce scrap, better quality. These are all things that we've been doing now for a good 4 years across about 50, 60, almost 70 manufacturing customers.
Wow. So I want to kind of pivot to a question of, there are a lot of buzzwords out there. We've got Industry 4.0, machine learning, artificial intelligence. Can you help us understand those and better define what that means?
Yeah, no doubt. So obviously you hear those words all around. You couldn't watch a football game this year without seeing some sort of AI related commercial, right? I mean, and everybody's an expert, right? The minute these terms become popular, these guys kind of come out of the woodwork, right? So let's kind of take it from the top. The first big buzzword that we've all been kind of beaten over the head with for much the last 5-6 years is Industry 4.0. Okay, so let's kind of start there. So Industry 4.0, the way that I like to simply define it, is leveraging data to make a more informed decision about our process that allows us to reduce the cost of that process and produce at a higher level of quality, right? So the idea of making a data-driven decision that is informative, that can be tracked all the way down to EBITDA, okay? The idea of saying, we're going to use data to make better operational decisions that allow us to bring more cash to the bottom line, right? That is kind of the Industry 4.0 in a nutshell. I mean, there's a million different ways to extend upon that. You can say, hey, it's decentralized manufacturing. It's this, it's that. But ultimately, it's using data to make better operational decisions that drive a higher margin at the end of the day. That's it. So when we start there, where most customers are, and most companies are, I would say maybe 80% of the companies we work with have gotten to this point where they have started to heavily invest in the very first step of Industry 4.0, which is collecting the data. Okay, so this is companies that are investing in SCADA systems, MES, starting to bring data directly from the PLC into a database, networking the machines. All right, so they're starting to build these architectures and this foundational backbone to collect data and bring it together, right? To bring it in and store it, right? So that's the first step that's happening in Industry 4.0. We take a look at what we're doing as the second step. And this is where you get into machine learning and AI and what's the difference, okay? So the second step of Industry 4.0 is saying, now that we have all this data, what do we do with it, okay? And so machine learning is the idea of bringing data together and understanding how all these different data points interact with each other to form patterns, okay? And once you understand those patterns beget prediction. All right, so think about the machine learning model as the brain, okay? Machine learning model is the decision maker that you have in your head that says, hey, should I touch that hot stove? Well, the outcome, according to historic data and everything else we've ever been told or listened to or heard, the outcome it's probably not gonna be so good, right? The same way, again, on a manufacturing line, if you have an operator that makes a particular decision, and that has an input, you would love to have a fail-safe that says, hey, you've got a 90% chance of routing this batch or creating another pass, right? By virtue of your input. Wouldn't it be great to let them know beforehand? So that's what the machine learning model does, is it says, based on all the historic runs through this entire process, this is the range and this is the behavior that you should engage in to have this positive outcome. So machine learning is the brain, right? That's using all the data that's been collected in the first step of Industry 4.0, right? AI is how this, I guess the best way to say it, is how the machine learning model interfaces with the operator and with the business, okay? The AI is the systematic automation of the decision that is recommended by the machine learning model. So think about it think about it again, if we look at a physiological reaction, right? Is to say, okay, I'm in a room with Russ and Chris Mullins. And they have both threatened my life. I have realized that I need to get out of this room. All right. My brain has told me the probability of me dying if I stay here is like 90%. All right. So that is the machine learning model that says, hey, this is what you should do. This is the probability and the rationale for why you should do it. The AI is the trigger that my brain sets off and says, run. All right. The AI is the action that's taken as a result of the recommendation by the machine learning model. Does that make sense?
Yes.
So when people say, hey, I've got AI, no, the reality is that you've got a system that's executing a machine learning model, right? And that's where, again, a lot of buzzwords, a lot of stuff thrown around. You can't have one, you can definitely have machine learning models without AI. So for example, you could have a machine learning model that makes a prediction that presents that prediction to an operator, and then they have to make a manual decision on whether or not they just, they want to act on it, right? That's machine learning without AI. Machine learning with AI is making that prediction and having some level of automation that does it for you without the influence of an outside operator. Make sense?
Yeah, very good. Thank you. Thanks for that explanation. That is super helpful. Hopefully it was helpful for our audience as well, because there's just so much information about it, and it gets all convoluted. Let me ask this question, Rick. You guys have been doing this. Delta Bravo has been doing this work for 4 years now. What are the top 3 or 4 lessons learned? For companies as they go to apply this?
Yeah, so if we're going to give some level of recommendation, and actually we do this on every single call. So our customers range from your Rolls Royces, Continental, Toyota, big players all the way up here, all the way down to manufacturers that are kind of mid-market, 100 million in revenue, give or take. And so so we've worked with folks from all over the spectrum, and ultimately there are kind of 3 factors for this to be successful. The number one is absolutely culture driven. You have to have people internally that want to be the best, that want to run the tightest business they can, that are willing to invest in becoming the best. All right. So that culture of wanting to use data to improve has to be there. And it's not in a lot of places. Okay. There are plenty of places out there that just want to keep going the way they're going. Right. So that's number one, is having that competitive fire inside the culture. Number 2 is understanding the business in a way that identifies the right use case, right? So if you go in and say, hey, I just want to predict downtime, well, to what end, right? And where? And how does that, get measured through the business? So understanding the use case. So number 1, we've got this commitment to being better as a business. The next thing down is, how well do we understand our processes? Where can we identify within our process a specific way where a change can impact, where a predictive quality, a predictive factor can impact our bottom line, and how do we quantify that? So what we always like to say to folks is that, having a process engineer and a subject matter expert in the room is a great start, but that's all it is. Okay. You need to have a finance person in the room that can legitimately and objectively qualify the financial benefit of solving this problem. And then you have to have an IT guy in the room that can give you access to that data in a way that fits the security model and the network model for the customer. All right. So ultimately, number 1 is culture. Number 2 is understanding your use case and having the right people in the room. And then number 3 is having the data itself. Right. There's plenty of places that we've worked with that don't have the data. We help them understand what data they have to collect to solve the problem and what frequency they have to collect it. That's another big thing, right? Is really understanding kind of this investment in data. There's plenty of OEMs that'll collect data at the machine level. They'll set those collection defaults, kind of at a certain way where, hey, maybe we're just collecting information and metrics once a minute. Well, if you guys want to have a real-time prediction, you're gonna have to take that down to once every 2 seconds, right? Because if it's very difficult to predict something in real time where you're only getting data coming out every minute or every hour, right? There's some level of fudge factor that you can do there statistically, but ultimately it's not the way you want to scale, right? And so that's the thing. You've really got to have this kind of understanding of how predictive quality influences the business, be able to quantify that, and then the base systems that you can use and adjust to collect that information. Big thing there also is starting small. we've all had those projects, right, with data and with advanced analytics. We are sitting there spinning our wheels all day, getting a million people involved, and at the end of the day, you're like, why did I do this? I'm no smarter today than I was yesterday. So what we like to focus on is starting small. Let's find an isolated problem that we can quantify, that we can deliver on. Let's start creating enthusiasm and credibility by doing this thing right the first time in a controllable, repeatable, scalable way. We always encourage customers, don't boil the ocean, right? Everyone wants those 5 use cases that we do. We try to start them off with a small percentage of the first one, right? If we want to do, predictive maintenance or, reducing unplanned downtime, let's start with one part of the process, right? And then once we've got that nailed down, let's extend it in a way that justifies the cost, that we can quantify and show an ROI. Like we try to tell people, hey, we shoot for a 10x ROI, okay? And we try to solve $1 million problem. That's what we focus on. There's generic problems that you guys can solve out there with things like robotic process automation. We're using like a Microsoft or an Amazon data science tool or a data analytics tool. That's all that generic stuff, and that's not really what we're here to solve, right? We're here to solve big problems for companies that want to, increase their EBITDA by millions of dollars.
Tell us about those 5 use cases, Rick. You touched on that, but what are those again?
Yeah. So predictive maintenance is number 1. The idea of understanding how throughput, quality, and machine performance work together to influence condition-based maintenance. That's number 1. Let's be proactive in that. We've got one customer where what we're doing with them is that we actually have about 400 machines where we're pulling all the data in from those machines and helping giving their maintenance team 3 to 7 days advance notice on anomalies that could potentially impact downtime or performance degradation in the future. We actually tell them, what those metrics are, what if there's a possible replacement that should be recommended. We even integrate with their ERP system to tell them whether or not their customer has the replacement part on site, right? So if you're forecasting downtime 6 days out and it takes 7 days to get the part in, you're going to want to proactively make that customer aware, and you might want to get in your car and drive that part there yourself, right? So that's predictive maintenance. We do a lot of that. Predictive quality. Our big story there is Rolls-Royce. We're predicting engine failures in the Rolls-Royce test center. That solution is 0 false positive. We saved them over $4 million in the last year. What we're doing there is taking data from systems that are on the line as well as the test cell software, and our models actually integrate with the test cell software, right? So the operator, if our model predicts a failure, which it does within 3 seconds of the process starting, it'll shoot a script over to the test cell software. And so the operator, all he sees is a little pop-up in his software that reads, test has been paused, anomalies seen in these metrics, please replace this part and restart the test. No change to his process, no re-education, no idea who Delta Bravo is. So we love predictive quality. Scrap reduction, doing stuff with Nucor Steel right now, where we are predicting the behavior of 13 different elements across 1,000 different specifications to help them know exactly where to cut steel at the ideal tensile strength with minimal intermixed scrap. Okay, so that's a multi-million-dollar savings opportunity there. So predictive scrap.
That's an interesting one too, Rick. We've talked about that one before. Now that's that transition time, right? So they're trying to minimize scrap as a result of going from one pot to another pot, for lack of a better term,
or in the same pot. You know what I mean? Where you have a huge tonnage and you're using that same tonnage to make different specifications of steel, right? There's military grade, consumer grade, there's all these different grades. And what you need to do is you need to understand. And
that's a matter of the ingredients that they're throwing into the stew.
So if we've got chocolate coming in, vanilla coming in, and strawberry coming in, and we decide that we just want to do chocolate, we got to make sure that we know exactly when there's no more strawberry and vanilla left in there, right? And cut it. So, but yeah, that's a good one. We do a lot of that in semiconductors as well as, chemical like monomer polymer applications, very similar in concept. Another big one is demand forecasting, right? Companies that depend on their sales reps to forecast demand. We all know how that works. It really just depends on how the sales rep is compensated. That's going to dictate the quality of your demand forecast. So if you're able to say, okay, why don't we combine our CRM data with our historic order data, with our ERP data, all right, with our plant's ability to execute on certain types of workloads and demand. Let's integrate weather data. Are there any other factors out there from third-party data sets that have historically influenced our business or our industry? If we can bring all those things together, we've done this with Continental, where we brought in, not just all their historic order data by product, but we also brought in weather data by geo. We brought in competitive data. We actually went on the web and scraped information from their competitors where they had run specials over the course of time and in particular geographies. And we were able to go back to their historic data and say, hey, did that competitor even influence your demand at all, and by how much? And if you combine that with certain weather patterns, does that influence your demand and by how much? So being able to more accurately forecast demand is a great way for you to more accurately forecast inventory movement, right? So how many parts need to be and where? A lot of people keep 15% of everything up, but here's the problem: if you've got a scrap problem at your plant, your sales guys are going to order way more than what they need because they're anticipating you having a problem delivering, right? So all these things are all connected, right? So that's why we focus on those 5 use cases, because if you can be predictive in an accurate way across those 5 things, you can make a significant impact on the company's value.
Excellent. Yeah, it seems almost that the use cases are endless, and it's a matter of what you've said today is identifying the right use cases for maximizing the return and increasing the efficiency and ensuring uptime and everything that you want to get with processing that data.
Yeah, and we do this in a way that's very affordable. We do it in partnership with South Carolina Manufacturing Extension Partnership. We are eligible to get grants as a small business here in South Carolina. We are eligible to receive grants that offset the cost of going in and doing our assessment and our recommendations. So there's a lot of ways where we are capable of working with your mid-market manufacturers and on up, where it's the type of thing where they can dip their toes in the water without having to feel like there's a great degree of risk.
Wonderful. Any last words? Anything else to offer, man? So appreciative of you joining us today.
Yeah, I will say this: if you are in this business and if you do not have a concerted effort to explore this, you are risking a significantly negative outcome. So let me extend on that for just 1 second. The companies that we are working with that build these models are using them as intellectual property to help extend their footprint in the industry. So, for example, we work with an agribusiness that is using us to predict the quality of compost, which is then used to increase the yield of the substrate. Right? They're going out there and finding farms that do not have this capability. They're buying these guys for pennies on the dollar, and they're taking this infrastructure and this solution and just forklifting it over there. So all of a sudden, their yield is 15, 17% higher practically overnight. So what's happening is that, you always see consolidation in manufacturing, right? And consolidation typically works when there's a value-based reason to buy that company. The other way it works is when that company's not doing too well because they don't have this capability, and I can buy them for a lower valuation because they don't have this capability. Then I can just ingest these guys, integrate them, and then all of a sudden we've got a more powerful business. So this is the type of capability that'll make you more competitive, more valuable. And if you're not doing it today, trust me, whoever's got to fight you, they're doing it. So this is pretty widespread. So thank you for us, man. Thank you for the opportunity.
Now, how do people get in touch with you?
Always fun.
How do people get in touch with you?
Yeah, just email me. It's Ricko, RICKO @deltabravo.ai. So Ricko, remember, no one wants to write Rick.Oppedisano. You'll get carpal tunnel syndrome. Avoid it. So it's just Ricko @deltabravo.ai. Come visit the website, deltabravo.ai, to check out, learn a little bit more about what we do, who we're doing it for, and how we do it.
Wonderful. Thanks again, Rick. So appreciative of you being here. As always, want to thank every one of our customers. We do not exist without you, and we are so grateful that you've allowed us an opportunity to hopefully pour into you and then provide you value at any level. We are here for you. This is CapEx Sales. CapExSales.com is how you can reach out to us and connect. So
all right, man.
Thanks so much. See you, everybody.
Everybody.
Bye-bye.